Doing the same thing that we did for the tan and secant and cos graphs, we're going to justify the secant x derivative based on shape. So we have secant, derivative of secant x is secant x tan x. Now again, this becomes a defined derivative, so this is something we need to know. We can't work this out somehow. So looking at the secant x graph, we can see that the secant graph is negative here, going more negative as we go to the vertical asymptote, and we can see that the y values are going more negative. And the same pattern is happening going in the opposite direction. We have positive, less negative, less negative, less negative to 0. So we see that we have our y values approaching 0 here, and we have a horizontal tangent. We have our horizontal tangent here. We've got a y value of 0 here. And this is a mirror image. Instead of going negative slope, it's going positive slope. So we should have a mirror image coming this direction. Okay, so again, this is positive slope, positive slope, positive slope working out here. It's going towards 0. So again, based on shape, we can justify the secant derivative as secant x tan x. We could do the same thing for cosecant. The cosecant, the derivative of negative cotan cosecant. Now, I want you to notice something, that for secant, we have this two-part derivative, and for the cosecant, we have the same two parts. Okay, this one is tan and secant, this one is cotan and cosecant. So there's a pattern here. Again, we're going to justify this. This is positive slope going to 0 slope here. So this is positive, positive going to 0. This is negative slope through here in the same pattern. So it's going to do the same thing on the negative direction. It's going to start off negative here and go to 0 slope. So then it's following that pattern this way. And as we go to the positive slopes, it's going to follow that same pattern as we had before. Okay, so we have this shape again, the derivative being defined here, but we can justify it based on shape. So again, the same thing here, the cotan differentiates to cosecant squared, or negative cosecant squared. Again, I want you to notice that it is very similar to tan that ends up as secant squared. Tan goes with secant, cosecant and cotan go together. So looking at the cotan graph, well, the cotan graph is very similar to the tan graph. It's all negative slope. The least negative is -1 and going to infinity. So we have negative infinity going to a slope of -1 and back down to negative infinity. And this pattern again just repeats itself. Okay, so we can justify this defined derivative based on the shape of the functions, based the shape of the cotan function and how it relates to the negative cosecant squared function.